Beaming out across the galaxy, this is where conspiracy on the wild side meets the perspective of a lifetime. This is the Free Zone with your host, Freeman.
Hello and welcome to the Free Zone. Well, we have been wondering what life would be like as the algorithm takes over, as AI starts to come in and virtual reality starts to shift our perspective and make us wonder if we live in a virtual reality. It's 2019 and scientists have created mind control rat cyborgs. Yeah, that's right. A team in China figured out a way to take control of a rat and steer it through a maze using a brain-to-brain interface. Now, there have been many brain-to-brain interfaces used in the ideas of prosthetics, to have your arm move and things, but no one had ever put an electrode into a rat's brain, creating a rat cyborg, and then controlled it with the minds of the manipulators that were using it. So we now have a brain-to-brain interface that manipulators can control cyborgs' brains. Yes, welcome to the future, folks. But what happens when an algorithm thinks you want to die? I mean, suicide has been a horrible story of the 21st century, going on. And Wired had covered when an algorithm thinks you want to die. And we found out that teenager Molly Russell sought out images of suicides and self-harm. And then the algorithm on Pinterest and others started to fill her feed full of these graphic images of self-harm. Now, what this has led to is the idea that we need to control the content that is coming in so that when people are looking at self-harm images, graphic and otherwise, glorifying self-injury and suicide, that they should be able to be stopped. But what if these are also ways and methods for people teaching to not commit suicide, ways out? What if these are ways of help? So how does the AI know? When does the bot know which information to send you? Well, I just want to say that Wired didn't only say about suicide, but threw in conspiracy as well. So I guess conspiracy feeds are considered on the same level as graphic self-damaging imagery. Yes, okay. So an algorithm decides that you want to see more suicide. Do you guys remember the Momo suicide challenge? This was a app that you could get. A game came out of Mexico, and there was the suicide challenge at the end of this thing. And two kids committed suicide after one gave the other the game after committing suicide. Well, he gave the game to another girl of 16. And they both committed suicide after playing the game. And so now we have this ability to use AI, to use algorithms to start to influence the minds of humanity, and even getting to the point where we could just put a microchip in there and control you as a cyborg. Welcome to the 21st century. Well, as we start to discover and understand this consciousness that we're in right now, there's no one better than Thomas Campbell to give us the insight on all of this, folks. Thomas Campbell is our guest tonight, and he is a physicist, a consciousness researcher, and he's the author of My Big Toe, The Theory of Everything. This is a trilogy that you need to get. Thomas Campbell has been an international lecturer. He describes the nature of our larger reality, provides this complete theory of consciousness, and explains our purpose and the connection to that reality. So let's find out today how a nice physicist like this ended up in a place like this. Welcome to the Free Zone, Mr. Tom Campbell. How are you?
Well, thank you very much, Freeman. Yeah, I've often said that myself. How did a nice physicist like me get into a place like this? Well, maybe I should start there, with that question.
Please do.
But if you like, we can mention the news reports if you want to go there first. But
all right, let's go ahead with that. That's some crazy stuff, right? Algorithms, cyborgs, AI.
Yeah, well, you know, I have found that if you read the popular science press, that is the stuff that the scientists put out there, not for other scientists, but for the general public, you have to take that with a grain of salt. Those guys, I think, are in a competition to see who can say the most outrageous, claims when they report things. Now, it's not that the things they report are basically untrue. They're not untrue, but they just present them in a way that is a lot more sensational than what's really there. So when we talk about helping, or not helping, but getting a mouse to go through a maze by us directing them with our minds, I think if you read what they actually did, they'd have a rat that they were training, and they were training to respond to certain signals. And they would like tell the rat, go left, go right, with their own mind, and that rat would get that signal, and the rat would go left or go right, because if the rat did what the signal said, then the rat would find some cheese at the end of that maze, and the rat wants the cheese, so the rat learns to obey those commands, because that gets him to the cheese. Some such thing like that. It's not, I believe, now I don't know, I've not read this, I'm just from my general understanding of the way scientists tend to make their claims sound bigger and better and sexier than they are. I suspect that is what you'd find. It's not that the rat was a poor helpless thing that was being manipulated to do whatever the people say. It was more that the rat and the people had been in training for a while, such that the people could then get the rat to go the way they wanted him to go. But it's partly because the rat wants to do that, because the rat's going to get some cheese at the end of it. If every time the rat followed the instructions that they were getting from the person, they ended up getting a shock instead, then you'd find that the rat would ignore everything that the person said and go the opposite way. Rats really are pretty clever little animals. So I think that, at least that would be my opinion about what's going on. And I want to make that clear. That's just my opinion. And that's an opinion out of ignorance, actually. I've not read any of that. Hearing you talk about it is the first time I've heard of that. But I have seen people using their mind to control computer images. They'll put on a headset, and they will have a dot of light come up on their screen, and they'll move the light up and down and around and sideways and move it in circles. And they can get the computer to basically obey their mental commands. But that's what I mean by being kind of sensational in the way you say it. It's not really obeying their commands. They have trained a computer, again, to respond to certain input stimuli, and those input stimuli can be taken from an EEG from a that the human is using. So that's a thing that goes on their head with the little electrodes all over their head that picks up the electromagnetic signals from their brain. That's the EEG. And if that EEG is this way, then computer, you do that. And if the EEG has this kind of potential or this kind of frequency, then you do something else. And eventually you can get computers to kind of follow the commands of a person sitting. It doesn't necessarily mean that the person is somehow merged to the computer and controlling whatever the computer does. It's just a training thing, and it's something we'll probably get better at. Right now we do it in a very clumsy sort of way. Eventually, perhaps we'll be able to do it more organically, where the computer will be able to follow more complex thought patterns, and you won't need a mouse at your desk. You may just, telepathically connect to your computer, or your computer has memorized a whole list of particular patterns in your EEG, and it has if that pattern, then do this. So every time it sees a particular pattern, then it does a particular function. And we may one day get that to where it's much better than it is today. So now we'll go to the other one, where we have this this discussion, and it really is a good discussion about this very, very slippery slope of controlling information. We've had that all along. It goes to, it started out, I guess, as a censorship discussion, but it's a very important discussion to have, because you can always make a case. So we should control this information because this information causes a lot of trouble. Well, that may be true. Like hate speech, like people who go on websites and say, you know, we should kill all the black people and we should do that, and we're, you know, all the Jews need to be, you know, sent to the moon, or, you know, you have people like this that spout out hateful things. And there are those who would say, well, we need to stop that. That's not good. That's destructive to our culture and to our society. On the other hand, once you start censoring what people can hear, you start censoring, this information is inappropriate and that information is appropriate. It's a very slippery slope, because if you allow that sort of power, the power of censorship, then what if the people in power that can control what gets censored and what gets not decide that what you're talking about is something that is not suitable because it doesn't agree with what they think or what they believe? So then you have this slippery slope where they take the conspiracy theories and slip them in, let's say, with the hate speech, or with, you know, with things having to do with trying to talk children into suicide or self-destruction. Then that's the slippery slope I'm talking about. So that's a very good discussion. Do we control information at all? And if we do, how do we make sure we don't slide down that slope to where that control, though in the beginning is for everybody's good, of course, but in the end often turns out to be manipulating everybody else for the advantage of a few. So I think that's a discussion really worth having. They bring up a very good point there. It's a place that you have to be very careful if you are in favor of censorship, that doesn't get out of hand. And I don't know actually of a way that we can construct our society so that we can be sure that abuse of that control would never happen. I think our society is such that we can almost guarantee that abuse of that control will happen. Right. In that case, we need to be very careful about controlling information. Perhaps we need to encourage parents to be more aware of what their children are watching and what they're doing and what they're thinking and the state of their mental health. That would be a thing that would perhaps also be part of the solution to this, which I would agree, it is a problem. That kind of nasty stuff is, you know, does warp children's minds. Children aren't that old yet to make good choices. They're easily influenced. And there is some ideas out there that we can protect children from things. You know, the site will say, if you're under 18, don't click here. Well, you might as well ask them to click, because that's just an invitation for anybody who is curious about what's behind that barrier of need to be over 18. And they may be 12 or 13, but they're going to click that anyway, as long as nobody's watching them and they won't get caught. So we have a new thing here, this internet, and this freedom to put anything up on that internet you want, and how that might affect others, particularly children who are too young to make good choices. And that's something we haven't figured out yet, and it's something we need to ponder and think about. And I believe that the parents and the environment have to be involved in this. It's not just how can we keep the internet from affecting children. I think it's also, we have to talk about how can we keep parents and children plugged in enough together so that the parents can protect those children from the things out there in that environment that might harm them. We already do that with, you know, we put locks on the gates where children play so they don't get out and wander in the street. You know, parents take responsibility for the children. Well, now that we have a new threat on the block besides automobiles in the street, we've got an internet with some ugly stuff on it. Parents are going to need to step up to that threat and kind of take charge there too.
Yeah, this show has always been family friendly, and to be lumped in with the idea of graphic violence and have them put that in the same category as scenes of suicide is scary. Yeah,
well, that's the problem with censorship. That's why I'd rather solve it on the parental end than I would on the censorship end. That censorship end is a very slippery slope that can end up biting you. Even though you thought it was such a great idea, 20 years later, somebody decides that whatever you're saying is not what they'd like to hear. So then you're the one that gets censored. That's yeah, that's not really the good way to work the problem. We need to work at positive ways, not negative ways, not by controlling information, by putting out more good information, and let people know about the threats and the warnings, and let parents know about what their children are exposed to. Well, anyway, let's move on. We probably run that into the ground. So
right.
let's go on.
I'm a person that hasn't even said okay Google yet. I'm scared to talk to my car. I'm scared to talk to my phone. That's where I'm at. I'm old school, but I've been around since the beginning of the World Wide Web and been here manipulating and influencing thoughts as best as I can since the moment of AOL chat rooms. So, so yes, let's get into the exploration of inner space as we find out how, you are high priest of science, right? Yeah. So when you come out, I mean, you're at the heart of developing U.S. missile defense systems for 20 years, doing complex systems and checking risk analysis. And, you're a professional physicist. And now you've put yourself out here to the point that you're on the free zone. Let's talk about how you ended up here.
Yeah, okay. How did a nice physicist like me end up in a place like this? Well, I guess it started a long time ago. I was 7 or 8, maybe even 6 or 7, and I had out-of-body experiences. I actually had entities come to me and ask me if I wanted to go out of body, and I said sure, because I thought it sounded like fun. And I got out and I flew around and out through the windows and across the lawn, and I had a good time playing with it. And that went on for some years, and then it stopped because what they said was they didn't want me to grow up being too weird, because that would not be good for my overall development. So that just stopped. But then when I was, say, 25, 26, somewhere in the mid to later 20s, I was in graduate school working on my PhD in experimental nuclear physics, and I saw an ad on the physics department door that was advertising TM, Transcendental Meditation. And for students, it was only $25. So I read the notice and wouldn't probably have been interested, except it said that if you do this, you can get by with less sleep. You can get energy from the TM and won't need so much sleep. Well, when you're a graduate student, particularly doing nuclear physics with large machines, you do the physics while those machines are running. They're problematic and often hard to keep them running. So as long as they're running, you're there. That means you may have to stay up for 2 or 3 days with those machines with no sleep, because that's your experiment. So I was all for something that could help me get through these long, tedious experiments with the big Van de Graaff generator machine that we were using. So I did. I enrolled in the TM. I found it very easy, very simple. I took to it very quickly. And what happened is about 3 or 4 months after I started TM, I found, just kind of by accident, by intuition, that I could decode my computer programming much faster from a meditation state than I could actually sitting in front of the printout and trying to find the errors. I could just scroll that printout in my mind, and everything that was an error or problem would be red, and all the rest of it would be black. So I could scroll through it, see a red thing go by, and say, whoops, back that up. Let's take a look at that. Okay. I was familiar with every line in that program because I wrote it. That's the way it is. When you do physics, you depend on computers and mathematics to get your job done. So I had, these are in the old days of punch cards where debugging was a very difficult thing. They didn't have debuggers like they have now. They didn't even have things that would point you to where the problem was. It's just that the computer didn't, or the computer wasn't able to execute your program properly, and that's all the information you got. And it was the old days of cards and card punches, and it may not even been any error of yours. It may have been the card punched the hole just a half a millimeter, to the right where it was supposed to punch the hole. So it was very difficult debugging. And it was amazing how quickly I could find errors just by using a meditation state. And at that point, I realized that reality was bigger than just the physical reality, because there was no physical connection going on here. I was finding errors in my mind. It was a mental connection. So after that, I had a whole new attitude toward reality and what it was. And I realized that the physics part of it was just a piece of some reality that was bigger. Well, some months later, or maybe a year or two later, I had the opportunity to run into Robert Monroe. Robert Monroe is the guy who wrote Journeys Out of the Body, Far Journeys, and Ultimate Journey. And if you read his books, you'll see that he talks about, I think in his book too, Far Journey, he talks about some of his explorers, and one of them is TC physicist. Well, that would be me. So I got working with Bob with the idea that I would be his free scientific help in his lab, trying to understand how consciousness and out of body worked, and he would teach me what he knew about getting out of body, because I knew if I didn't experience it, then it wasn't my truth. I could study Bob and I could read books, but if it wasn't my experience, I really would never understand it. So I tried to do that, and Bob was a good teacher, and within 6 months or so, I was getting out of body on demand whenever I wanted to, and I started doing research there, because my mind is a scientific mind, and I want to understand how things work, why they work, what can you do, what can't you do, and why. So I started doing research. After about 2 years there, I could do the out of bodies with such precision that I could go to the exact same place in the exact same way, change one variable, and then see what difference that variable change made. And it'd have to be something that I could measure, like something I was doing, like remote viewing, or things that you could check to see whether or not you were better or you were worse. So I did that, and eventually I figured out, basically, I thought, how consciousness worked. And I understood, things like healing with your mind, talking with telepathy, auras, getting data from databases, past lives, all that paranormal stuff. I understood all that because I was able to go search out the source of that. How did mind work? How did consciousness work? Where was this data? Where did it come from? And why was it there? And when I thought that I understood the answers to all those questions, then I wrote these books. It's 3 books, a trilogy called My Big Toe, where TOE is an acronym, TOE, for Theory of Everything. And really, it was a theory of consciousness is what I was writing, though I knew from my own experience that consciousness was fundamental and that this physical world was a product of consciousness. It was not the fundamental world. The physical world, as we call it, the physical universe, was created from consciousness. I knew that because I could manipulate that physical world with consciousness. Consciousness was more fundamental than the physical world. So I had this theory of consciousness. I knew that consciousness would also describe the physical world, but I didn't really know how to do that. So I published the books. About 2 years after I published them, I got one of these aha moments that was triggered by what somebody sent to me in an email. And I realized that the very same ideas, the same concepts that let me understand consciousness also let me understand quantum mechanics. I could understand why the double slit worked the way it did. And it wasn't weird science like the scientists say, it was logical science. I could understand it. So then I said, well, if I got quantum mechanics, what about relativity? And that only took me about an hour then to figure out what the solution was to why the speed of light's a constant. You see, relativity theory is really fundamentally wrapped around this one concept, and that is the speed of light is a constant. It never changes. So if you have a source of light traveling very fast, say 8/10 the speed of light, and that source, that light source, turns on like a flashlight that's going very, very fast, and you turn it on, well, the light that comes out of that flashlight still goes just the same speed of the speed of light. It doesn't go faster because the source is going faster. Now, all the rest of everything in our universe does not work that way. Speeds are additive. So this was a very unusual thing, and Einstein just postulated that. It was a kind of an assumption of his that light speed was constant, and because of that, a little bit of algebra drops out special relativity. Then once you have special relativity, you include gravity and geometry, and you end up with general relativity, but it's really based around the fact that C is a constant. And then I understood why C was a constant. So then I started looking for all the other things in physics that were mysteries, that were paradoxes that scientists just didn't understand. And all of them, one right after the other, fell out. And as a logical understanding of how they worked. So now I realized that, okay, I could compute physics from the perspective of consciousness. That led me to the idea that this is a virtual reality, that our reality here is just information. We're living in a simulation, and consciousness is the computer. Okay, so consciousness, what I call the larger consciousness system, is the computer that's computing a virtual reality, simulating a virtual reality, and we are pieces of consciousness that are the players of this virtual reality. You see, we're players, just like if you were a player in the Sims game, then you make all the choices for your Sims character. Your Sims character is called an avatar. You are the consciousness of that avatar. You're the consciousness of your Sims player. Okay, so you make the choices. The choice maker is outside of the virtual reality. The player isn't inside the virtual reality. The Sims is the virtual reality. The player is outside the Sims virtual reality. And that's the nature of virtual reality. So here we are, our bodies are avatars. We are consciousness existing outside of the virtual reality that we call our physical universe. And as consciousness, you know, we're the players. We make all the choices for that avatar. So that is the concept, that virtual reality concept that explains not only consciousness, what it is, how this virtual reality got made, what its purpose is, why we're here, how quantum mechanics works, how relativity works, how all of the other mysteries of science can easily be explained. So this basic idea that this is a virtual reality is one of the fundamental cornerstones of all of that understanding. And the neat thing is that when I was coming up with this back in 2003 in February is when I published it all, there was probably me and maybe 2 or 3 other guys, physicists from MIT and then Boston University called Edward Fredkin. He thought that virtual reality was a really good idea and that we were living in a simulated reality. And he was a fairly big gun too in the science community. And then there was Nick Bostrom, an Englishman who had some bona fides in both physics and in philosophy, and he thought that was a good idea. And I thought it was a good idea, and I think that's about all the people in the world that thought it was a good idea. So there weren't many people, but today, I'd say 20% of the physicists in all the physics departments anywhere in the world think virtual reality is a good idea because their science, their experiments have led them to that conclusion. When you do quantum physics, you'll find that it just screams at you that our reality is information-based. Matter of fact, when you do high-energy physics, like at the big atom smasher, okay, over there in Switzerland,
Mm-hmm.
at CERN, I was listening to an interview of a couple of physicists while they were over there looking for, what do they call it, the Higgs boson, the God particle. God particle. Talk about scientists, making up.
I just always clarify that.
Yeah.
I clarify that Higgs actually called it the goddamn particle. Go look it up. That's true. It was shortened for the mainstream media. He called it the goddamn particle because he couldn't figure the damn thing out.
Well, anyway, I was listening to this interview with these physicists who were over there, and they were trying to explain to this guy. They said, well, sometime back, we thought that an electron was a chunk of mass with charge. It had a unit charge, 1, and it was a little piece of mass. And that's what an electron was. And that was our theory. And he says, well, we know now that that's just not true, because if we assume that, then we can't compute any of the right answers. It just doesn't work. What we think an electron is now is a point with the attributes of charge and the attributes of mass. Well, if you're going to simulate an electron, it's a point with attributes of mass and charge. So the physical world, the physical thing, if this is mass with charge, doesn't work anymore. Scientists, like I say, a lot of scientists, not just a few, but many, many scientists, most of the young ones, this is an idea that's new. So the younger scientists tend to support it more than the older. But this is well understood in physics communities, that our reality is based on information. It's only information that allows us, if we just see it as information, it allows us to compute the right answers. In other words, we understand why the experiments work the way they do. If we try to assume that a reality is mass and space and all the physical kinds of things, then the experiments say that's just not true. Like even 100 years ago, the double-slit experiment said that's just not true.
Now let's cover that real quick, because the double-slit experiment, I understand, but maybe the listeners don't. This is the idea of the observer affecting the results, right?
Right. Well, I'll give you a very quick summary of that. If you have a light beam and you shine it on two slits, some of the light will go through one slit, some of the light will go through the other. Each slit kind of serves as a source for the light on the other side of this barrier. So you're shining this light and there's this big barrier, a big piece of cardboard or metal or something that's got just two slits in it. Well, these two slits become light sources from the light that shines through them. And those two light sources then interfere with each other, and you end up with an interference pattern. Okay, so, and the reason that is the distance from one slit to a screen. When I say pattern, there's a screen. There's another big piece of cardboard just, a little past the slits, and the light goes through, and goes through the slits, and it'll hit this screen. Well, where you have the light going through slit A and hitting a place on the screen, and the light goes through slit B and hits that same place on the screen, if the difference in length between slit A and that point on the screen and slit B and that point on the screen is exactly one wavelength, then you'll get superposition. Both of the waves will be, say, peaked at the same time and dipped at the same time, so they just add together. Whereas if it's a half wavelength difference between those two paths, then one way, when the two waves get there, one is at its peak, the other's at its negative, at its bottom. So one's positive, one's negative, and they just cancel each other out. So that's what we mean by the light interferes with itself. And you end up with a pattern on the screen of little bars of light, little lines of light, like the slits. So there's these little vertical lines, then there's a dark space, then another line of light, then a dark space, and another line of light, and so on. Those are called, sometimes they're called interference fringes. Sometimes it's just called a diffraction pattern, an interference pattern. Those are all different names for the fact that the light interferes with itself and creates this pattern. All right, so we knew that that's what happened when a light wave, when a beam of light hits two slits. The same thing happens if a water wave. If you have a water wave and it runs into a barrier and there were two holes or two slits in the barrier, you get the same sort of thing. You'll get an interference pattern from the water waves. It's just the nature of waves to do that. Well, Einstein got a Nobel Prize for his work with the photoelectric effect. And in that work, one of his conclusions was that light came in little discrete chunks of momenta. In other words, light was a particle. Well, now that was a problem, because if light's a particle, then why do waves of light, must be a whole bunch of particles, why did they interfere with each other? So the scientists of the day got together and they found a way to send photons, or light particles, if you will, one at a time at these slits. And the idea is, okay, here's just one particle of light. It's going to go through one slit or the other, and when it does, it's expected to go through that slit and hit the screen right behind that slit. So after sending thousands and thousands of particles that would randomly go through one slit or another, you should have two piles of photons, one behind each slit. That's what would happen if you had a little chunk of mass. If you send electrons or buckyballs or any kind of little chunks of particles through those slits, you get a pile of particles behind one slit and a pile of particles behind the other slit. But that's not what happened. What happened was those particles, coming one at a time, arranged themselves on the screen in a diffraction pattern, just like the waves. So they'd go through a slit and then they'd turn right or turn left or do whatever they had to do to only land in those places where the light would hit and where they would have interference. There'd be no light at all, and so on. They produced the same interference pattern. Well, that was not well understood. How could that possibly be? Newton told us that a particle goes in a straight line unless acted on by outside forces. Well, there were no outside forces. You had particles going in straight lines, which then, for no good reason, would just make turns and bends and rearrange themselves on the screen in a diffraction pattern. Impossible if you had little massy particles. And a photon has a mass when it's moving. It has zero rest mass. That means when it's not moving. But as we know, light always runs at the speed of light. So it does have it does have impact there. It does have momenta at that point. So what the scientists did next was say, well, let's look at these slits and see what's going on. So they put detectors at the slits, and now light would come through. The same thing, just randomly go through one slit or another. But if it went through slit A, a detector said, got a particle in A. And if ever went through B, another sensor at B would say, got a particle here through B. And when they did that, all the light particles just piled up in piles behind each slit, just like they expected. Okay, so now they realized that it was the measurement of the particle at the slit that, and what they said, collapsed the wave function to a particle. And once you had the particle, now it had to travel in a straight line. But without the measurement, you didn't really have particles. Particles weren't particles. They were only potential particles. So these particles, including electrons and hydrogen atoms and helium and buckyballs, which is a molecule of 60 carbon atoms, it works for everything, not just light. So when you look and see which slit it goes through, that collapses that probability function into a particle, which then has to go in a straight line. If you don't look at what slit they go through, they remain just protoparticles, probable particles, let's say, or another way of saying this, potential particles, until they hit the screen. And when they hit the screen, now that's when the wave function collapses. And at that point, it'll only collapse to a wave pattern. Okay, so that was this idea that if you look, if the information is taken that allows someone to see that there is a particle at a slit, then it acts like a particle. If you don't look, you don't take that information, then it acts like a wave. And that was the first time that a physics experiment told the experimenters that this reality is not made up out of physical chunks. That's the first time, because you don't have physical particles going toward a slit, either going through it and then doing weird things like rearranging themselves. You only have potential particles, information, see, probability. This wave function is a probability wave. It's not a physical wave. It's just a mathematical construct. So you have potential particles, something that could be a particle, perhaps, depending on, where the consciousness, where the measurement sees it, intercepts it. Well, that's because in a virtual reality, the virtual reality only exists in the minds of the players. Okay, so let's talk about The Sims or the World of Warcraft. Those virtual realities only exist in the minds of the players. It's not like those elves wandering around in the World of Warcraft scene. They wander around all day, all night, whether anybody's playing or not. They only exist in the minds of the players. There is no World of Warcraft map. where these things exist in and of themselves, only in the players. If you don't have any players log on to the Sims, then that server that serves up the Sims does nothing. It just sits there and does no calculations, sends no data out, because it only reacts to a player who logs on, and that player gets a data stream. That data stream is sent to the player's computer. Let's say in World of Warcraft, you look at all those little dots of light and you interpret that data into that World of Warcraft world. But that world doesn't really exist in a physical sense. It only exists in your mind. It's your interpretation of the data. And our world works the same way. And that then lets us understand the double-slit experiment. It's not until a person has availability to data describing something that happens in that virtual reality that you have something actually in the virtual reality. In other words, you need a player, you need a consciousness, you need a choice maker to get the data in their data stream, and that's what puts it in our reality. So when they measured those particles at the slit, that's where the potential particle becomes a real physical particle, and then can't do anything other than act like a physical particle. So you see, that's the double slit. So at that point, people knew that reality was not physical. It was information. But the scientists at the day, and they were very brilliant people, just didn't have the concepts to understand that. So in the beginning, around this was like 1915 to 1925 is when most of these quantum mechanics experiments were done. So that's just about 100 years ago. They were so excited. Wow, we found something new. You know, physics and science is going to take a whole new, hard right turn or hard left turn. We're going to everything's going to be different now. This is amazing. Well, that optimism, after a decade or so of trying to understand what was going on, kind of disappeared, because they just had no concepts of how they could explain what was going on. That's because this idea of virtual reality in the early 1920s just wasn't there. The concept wasn't in the world anywhere, so they couldn't think of that. So they all struck out. Einstein spent the last 20 years of his professional life trying to come up with a theory of everything, something that would tie quantum mechanics and relativity together. And because each one of those has an assumption that denies that very assumption that's required, say, in quantum mechanics, is denied by relativity. And that very assumption that's necessary for relativity is denied by quantum mechanics. So everybody knew that quantum mechanics and relativity weren't fundamental, that there had to be something bigger, some understanding above them from which they were both just pieces. They were both just subsets of something bigger. So he looked for that something bigger. He called it a toe, a theory of everything, but he was only looking for a little toe, which would just kind of unite all of the physical science, unite those two big branches of physics. But really what was necessary was a big toe, one that not only could unite quantum mechanics and relativity, but one that also understood consciousness, made the paranormal normal. So it's the paranormal isn't really para anything, it's just normal. You just have to understand the perspective from which it works and what makes it tick and what what drives it and what are its limitations and why does it work that way. And once you understand that, then it's just normal. We call things mystical and paranormal because we don't understand them. But once you do understand them, they're just normal stuff. You take a color TV to somebody who lives in the deep end of the Amazon jungle that's never seen anything of modern culture, and they'd look at it and they'd find that television set or that telephone to be entirely mystical to them. But it doesn't mean that there isn't good science behind it. It just means they don't understand it. Well, that's the way our culture is about the paranormal. There is good hard science that describes the paranormal and describes it exactly, and it's repeatable, and you understand the whole thing. But to most people, because they don't understand it, it's just weird and crazy and doesn't make any sense. It seems mystical, and therefore we throw it away. So anyhow, that's kind of how I got here, what it is I'm doing. It's a little introduction to my world. And I guess the other thing I should say is that when you understand our reality and where it comes from and why it comes, you also can describe scientifically the subjective, not just the objective. You find that the objective world is just a subset of the larger world, and consciousness makes up the larger world. That's the thing that's fundamental. But all of your subjective experiences, the significance, the meaning, the love, the caring, the relationships, all these things that have to do with our consciousness, they're not objective. They're all subjective. But those things can all be well understood. They are also amenable to science. It's not that science can only look at the objective world. A science that believes that the world is made out of matter, well, they're stuck in the objective world. But once you get the bigger viewpoint, you can see things like, why are we here? What's our point? Why is it am I unhappy? Why is it that I'm struggling through my life and things don't ever seem to work out, and I keep trying and trying, but it's just always an uphill battle. And every time I think I've crossed that last barrier and I'm going to be in the promised land, geez, another barrier pops up after a little while. Why is that? And all of your experience, if you understand this big toe, this theory, all of your experience becomes explainable, becomes rational, and you understand why it is like that, which means you can take the steps necessary to change it. You can live in a life that's basically full of peace and joy and happiness and satisfaction, and you know how to get to that spot. It is possible to get to that spot, but you have to understand how the world works. So it's not just about science. It's also about everyday life and relationship and the quality of your life. So it's really a big picture, a theory of everything, and that everything is the subjective and objective both. So I'll stop there. That's probably enough. I've probably melted down the brain core of most of your listeners at this point. So let me give you a chance to ask some questions and get me back on track to your listeners.
All right. Well, it has been amazing and fantastic. So basically what I'm getting is, in essence, we have it all backwards. We think that there was a big bang, matter formed, everything came together, and then as these particles came together to form beings, then consciousness came up and grew out of that. Whereas the theory, my big toe, flips that on its head, showing us that consciousness existed and it formed this virtual reality to experience itself.
Right. Consciousness was there, realized it needed a virtual reality to help it evolve. It was on its necessary path of its own evolution. So it created this virtual reality, not like we create World of Warcraft, which some programmers go out and program it, but it created some initial conditions and a rule set, and that's it. Now, the initial conditions was this ball of plasma under very high pressure and high temperature, and when the run button was hit, that was the initial conditions. When the run button was hit, that ball of plasma got to change according to the rule set. Now, that's the big digital bang. Okay, and that ball of plasma expanded, and as it expanded, it cooled. As it cooled, it created suns and planets and all the rest of that stuff, and so on, to where the evolution takes us to here we are, human beings sitting on this particular planet in this particular solar system. So that's the big digital bang, all done in a simulation. And we have simulations like that in some computer science labs in major universities, where they start with a rule set and initial conditions and set it up and let it run. And you generally have to tinker with the rule set, otherwise what runs, what evolves, what it does is just evolves according to the rule set. Given the initial conditions, how do those initial conditions evolve according to the rule set? And you have to tinker with that rule set a bit before you get something that's stable, that doesn't just go for a little while and then self-destruct. Well, in our case, that also happened. We have good evidence that, it was a digital big bang, take one, and then it probably blew up and didn't last very long. Digital big bang, take two. and so on. There were probably lots of iterative tries, fiddling with the numbers in the rule set, trying to balance everything such that it stayed stable. And we call that now, physicists call that the Anthropic Principle. They've found that there are 5 or 6 constants that if these constants changed, say in the 10th decimal place, the whole universe would become unstable and wouldn't exist, it would crash. And they look at that and say, well, it looks like this rule set, these constants that have to do with the way our world works, were just made just for us, just so that we could evolve and exist here. Because if any one of them changed, let's say in the 10th decimal place, the whole thing would fall apart. So how come you get these half dozen constants accurate at 10 or 15 decimal places, and it's just perfectly balanced so that this universe ours remains stable? Must be done just for us. So they call that the Anthropic Principle. It's another one of those paradoxes. Well, that's easy. That's exactly what happened. The simulation was run. It didn't do very well, didn't last very long. So these constants, part of the initial conditions, were just tuned and refined until all of them, right down to the 15th decimal place, were also nicely balanced that the simulation could run long enough to evolve something like us. So that then answers why you have this Anthropic Principle with all these fine-tuned constants. Well, that's just it's just a hand pointing at the fact that the rule set had to evolve as well as the simulation evolved. First, the rule set had to evolve, then the simulation evolved. So that's, so all those things help. So the Big Bang, you see, if you look at the Big Bang, it doesn't make any sense in a physical universe. Okay, there was this ball of plasma, and it expanded and made our physical universe. Well, where did that ball of plasma come from? That ball of plasma must have been outside our universe, because our universe didn't exist yet, you see? So where did that ball of plasma come from? And at first, scientists thought that, well, maybe everything expands, and then when it gets as far as it can get, gravity sucks it all back, and you have the big crunch, and it all ends up in a ball of plasma again that blows everything away and expands and then comes back into a point. But they found out that that wasn't the case. It doesn't work like that. Not only is it expanding, the expansion is accelerating. It keeps expanding more. And that acceleration, is not going to turn around. So the big crunch idea disappeared. So we have this ball of plasma, and there's no accounting for that. So this ball of plasma just came from nowhere. And from that, we can, given that, we can do this physical Big Bang and end up, with our physical universe. Well, where did that come from? It couldn't have existed in our universe. Something outside our universe must have put it there. Well, how did that work? Well, think about if you were an elf or a magic user or somebody in the World of Warcraft, and you wanted to understand, where did your reality come from? Where did the World of Warcraft reality come from? So you'd go back and back and back, and you'd get it back to the first day that World of Warcraft existed as a virtual reality. And you'd get to a point that it wasn't there. There was nothing, and then one day, there it was. It just started, because that's the way it is. That's when the server was turned on and started serving data to players in that particular virtual reality. That's when the World of Warcraft started. Well, that's the same. So virtual realities start at a point. They're like, not here, oh, now they're here. Just suddenly they start out of nothing. That's the way a virtual reality works. Well, our reality did the same thing. There's nothing. Oh, look, a ball of plasma. And the simulation runs on, and now we have a physical universe. So the fact that it starts out of an unexplainable nothing is a fingerprint, if you will, of a virtual reality. Otherwise, scientists can't explain, well, where did the ball of plasma come from? They don't know. It comes from nowhere. It's mystical. So, see, if anywhere you go back in physics, you'll find that there's always a mystical beginning. Right? Well, look at this way. There's another thing. Look at the things that all of physics is built on. It's built on certain concepts like mass, gravity, charge, space. See, these are the basic fundamental things. I don't know if I said mass or not. Mass would be in there. Spin. So there's 5 or 6, 7 of these basic things, and everything else in physics is calculated from these things. But where did these things come from? Where did mass come from? Where did time come from? Where does the space come from? How come we're expanding, that our physical universe keeps getting bigger and bigger? How do we get bigger? Somebody making space? What are we expanding into? If we're expanding, then there must have been something out there we're expanding into. You see, all these issues are pointing to the fact that it's a virtual reality. It's easy to accelerate a reality. You don't need dark energy to give extra push to make things accelerate. It's a virtual reality. It's just being computed. Goodness, I can make an equation for a sphere and put it in my little laptop, and in 30 seconds I can make that sphere, bigger than our whole universe. All I have to say is I'm gonna go through a do loop. So every millisecond it goes through the do loop, I'm going to take the size and cube it, and then take that size and cube it, and take that size and cube it, and take that size and cube it, and I can do that. And in a couple of minutes, I've successively cubed the radius of the sphere such that it's bigger than our universe. So it's easy to make things expand and get big in a simulation.
Right.
You see, it's just not that hard. So all those fundamental things that we don't know where they come from. Where does gravity come from? Where does time come from? Where does mass come from? Now, they said that Higgs was responsible for mass, but that's ridiculous. There is no connection really between Higgs and mass. That was just, somebody made it up because they had no idea where mass comes from, and they were looking for, something to say about it, but they don't know where any of these fundamental things come from. Okay, there we start again. You have stuff that has no origin. Where's the origin of time? What's the origin of space? You see, so when you have things that, all of physics is basically based on mysticism,
right?
On things popping out of nothing. You see, so these are fingerprints that it's a virtual reality. They pop out of nothing because they're information based. When the computer gets turned on, these things are defined, what they are and how they interact with each other. It's just part of the rule set. That's what gravity is. Space, the way you make space is you pick a point and say, that's the origin. And then you define 3 unit vectors, that is 3 directions that are all orthogonal to each other. So the x-axis, y-axis, and a z-axis. Now you have space defined from there to infinity in every direction for a 3-dimensional space. You define it that way. That's what makes space. It's just computed in a computer. It's not something that's fundamental. So when you understand this idea that this is a virtual reality, it means it's an information-based reality, everything else falls into place. All the paradoxes, all of the understandings, all the paranormal things, all of that stuff just falls into place, and you go, that's how it works. That's how we can logically explain all these details. So that was a double slit, and that's why scientists, and the double slit was just a beginning, like I say, almost 100 years ago. Since then, there've been hundreds of different experiments done that keep showing the same thing. And no doubt if you read popular science, you'll find that the physicists say, this is just weird science. Nobody will understand it. More of that weird quantum mechanics and that weird science. Well, that's just because they gave up trying to find the reason. If you keep banging your head against the wall, eventually you don't like admitting that you just can't understand it. So you come up with something better. You say, nobody can understand it. It's not understandable. It's just weird.
Right.
Well, that's just that's a way of
that's
excusing yourself for not being able to figure it out. Well, for their, and their benefit is they didn't have the concepts, but now we do. And that's why virtual reality is gaining. It's probably the biggest new idea in physics departments. And it went from almost nothing to a very large major idea. And interesting enough, if you look at the very top end of physics houses, the very top end, the MITs, of the world, the Caltechs, those that are up at the top of the heap as far as science, physics, mathematics, and engineering, you'll find those are the people that think virtual reality is a really good idea. Those are the people that are, and they tend to be a little younger, and they tend to be much more in favor of this reality being information-based, because it's the only thing that answers the results of the experiments.
Well, isn't it intriguing that we would evolve to then develop virtual reality?
Yes, that's interesting. And you know why that is that our reality is what I call a process fractal. Our reality has evolved. Evolution is a process fractal. And what that means, you know what a fractal is? You take some kind of geometry, like a triangle, and then you put triangles on the edges of the triangles, and they form different sorts of things. And then you put triangles on those, and big triangles and small triangles, and you just keep building up this fractal pattern, different scales of the same thing, of triangles, and you end up with these beautiful, unending designs that go to tremendous amounts of detail, and they're really can be very beautiful. And that's a geometric fractal. Okay, it's and any piece of it represents the whole. So you take any tiny little piece of it, and what you'll find is triangles, which is what the whole thing's built up as. Well, a process fractal works the same way. You start with a process, and you get an output of that process. That output then becomes the input to the process. The process works on that new input, which produces a new output. That output goes back and becomes the input again. So when you have a process that is basically iterative, where the output becomes the new input, and then the process works its magic on that new output, that output goes back into the input, that creates a process fractal. And it repeats in the same way, and it goes on forever in the same way. That's what evolution is. Evolution is a process fractal. And when you have fractals, patterns keep repeating. So we are a virtual reality, and we are creating virtual realities. And one day the characters in our virtual realities may create virtual realities.
That was the question, yeah.
Yeah. So these things can be nested, but in a practical sense, they won't be nested very deeply, because it's just poor computer science to nest things like that. The ones at the bottom that are the inside the nest, several layers down, they have huge overheads, because all the calculations of their overhead has to run through all the other virtual realities first before it gets to them. So it becomes a very inefficient computer science process to do it that way. So you'd tend to break those nested things apart and work them separately, or maybe just leave one or two layers nested. You wouldn't nest very deeply, because it's not efficient. Being that consciousness is the computer and consciousness is the information system, then it's not going to do things that are very bad computer science. It's going to do things very, very efficiently.
Well, folks, don't worry about if this is confusing or has taken your brain onto a wild ride, because we are explaining the theory of everything. So that's where you need to go. And I think that Tom Campbell has made this very simple for us to really understand. If you want to get deeper, though, go over to mybigtoe.com and get yourself the trilogy. The My Big Toe trilogy, and dig as deep as you can, because this is it. This is our reality that we're beginning to understand. And it has taken 100 years to take it from quantum physics to My Big Toe, but Tom Campbell has done this. And I'm curious, Tom, if you have lectures, talks, or anything coming up in the near future.
I have lots of stuff coming up in the near future. But before we move on, I'd like to say, you mentioned the books. Whenever anybody mentions the books, I want to point out that the books are free. If you go to Google Books, you'll find My Big Toe there, and you can read it right there on Google Books for free. Otherwise, you can buy them wherever it is you usually buy books, Amazon, bookstores, wherever. But I offer that for free. Also, whenever I do workshops, whenever I give talks, I always record them, mostly video, sometimes audio, and they're all on the internet at my YouTube channel. And of course, they're all free. So the downside is that it's very intimidating. You'll go to my YouTube site and you'll find, like 2,000 hours of video or something anything like that. I think now there's over 500 videos that are there, and most of them are long enough to make you cringe. Some of them are short, but a lot of them are, go on for hours. Some of them go on for days because they're major workshops and things that go on for several days. But it's all there. Everything pretty much that I've ever done in public is up there, and it's all free. So if you're interested in finding out more, and I can't but scratch the surface, and I can't do but more than fly over, the high points and kind of point to a couple of the high points here. To actually do a workshop that explains this theory with some detail takes me at least 2 days to do that, and that's 7 or 8 hours a day. So doing this in 2 hours, we're just not going to be able to derive it. I'm just going to have to state it, and if you want to see the logical derivations, you'll have to go dig into what's on YouTube or read the books, or better yet, both. So I do have a lot of free stuff out there. And yes, I go a lot of places. I'm usually, well, this year, 2019, I don't stay home much more than 3 weeks before I'm off to the next place this whole year. I just got back from a trip to the UK, where I did 2 immersives. An immersive is where the attendees and I spend about 12 hours a day together for 4 days straight. And they do nothing but my program, eat, and sleep. And I suppose they're also allowed to go to the bathroom once or twice, but that's it. Other than that, there's nothing else going on. And we do that for 4 straight days. And in that immersive, what I do is train them how to experience this larger consciousness system, how to get out in the larger consciousness system. And it's not me lecturing, it's all experiential. I give them tasks. I give them a set of binaural beats that I've constructed that'll put them in a good meditation state so that they can accomplish these things. I teach them how to, remote view. I teach them how to heal. I teach them how to use telepathy to interact with people that are in this reality or outside this reality. So I explain to them how it works and what the variables are and how to do it and what not to do. And then they go off and listen for an hour and practice, and they come back and ask questions, and then they go off and practice again for an hour. So that's what we do all day long. They practice for an hour, I talk for about a half an hour. They go practice for an hour, I talk for half an hour. I become the coach. But it's a very intensive thing. It's hard. By the time you're done, you're exhausted. I'm exhausted too by the time we get done, but everybody's exhausted at the end of it. But people walk away, for the most part, knowing how to get around in the larger consciousness system. All they need to do after that is practice. So I've got these going on. I'm going back to Germany in another week and a half. Then I'll be back here, and then I'm going to Brazil, and then I'm back to Germany again. And it just goes like that. And I've got several in the US that I do. I do those mostly now in Tennessee at a big cabin in the Smoky Mountains around Gatlinburg area that sleeps like, 40 or 50, 60 people. So that's the kind of programs I'm mostly doing now. I also go places and give 1, sometimes 2-day talks to beginners just to get them kind of sped up on what the theory is all about. So go to mybigtoeevents.com. So that's mybigtoeevents.com, and they have the schedule of where I'm going to be, where, and how to take place in them. Now, the 2019 schedule, I think, was booked up before we even got to 2019. So you may have a little trouble getting in, but I'd say stick with it, because when people schedule that far in advance, there's always people that are going to have to drop out for one reason or another. So openings will appear in it. And now my organizers, Keith and Donna, they are also booking things for 2020 already. So it just is the way it's been, is that they book up so quickly that you have to kind of jump on it. Otherwise, you have to wait for something to break free. But 2020 is booking at the present time. We're going to go to a little village in Italy, take over a whole village We hopefully will have, around 100 people. That's typically what we do. We do 100 people, and we just we took over a castle in England this spring in, all of January. We took over, most of January, some of February, and we had the entire castle to ourselves. We had 100 people there each week for 2 different weeks. So that's the kind of things that are going on. Go to MBT events and you can find out what and where.
Amazing. Absolutely. I love what you do, and you're a man after my own heart. I believe information should be free and uncensored, and it's up to you to decide how much you want to bring into your consciousness and what you want to put back out there. So Tom Campbell absolutely is a man after his own word, giving this information out to all of you. So definitely pick up a free copy of My Big Toe. And if you want to support them, there's also donate buttons on the website, or pick up the books because they are amazing. As we get into the next side, before I do that, I want to thank Steve Mercer, the producer, associate producer here at Free Zone, for bringing us together, Tom. I always have to give Steve big shout out for keeping this show going and keeping people as amazing as you coming across my desk. So if the folks out there want to write to Steve and get a guest on the show, it is producersteve@freemantv.com. And just let us know what you're thinking and how much you love this show. And I can tell the audience is growing and growing every week. It's amazing. And, 14 years running and it's still growing. That's impressive. So as we dig into this next hour, we're going to look into the purpose of this virtual reality, start to understand the simulation and why it exists and why we're here. And of course, I would like to dig in a little bit to some ritual magic and synchronicity on the other side as we move into the members section, and a place where it's a little more or less formal and we can share just our own selves inside there. It's a little group place for all of us. So I hope you'll come over to freemantv.com and subscribe, get the bonus hours, help support the show, and you will love it. So just come on over to freemantv.com. And of course, if you want to get any of the news articles that we talk about on the show, follow me at Freeman TV on Twitter, and you'll get all those news articles, or they're all included right there on the website. So any which way you want to go. We are in an information-based system here, folks, and now we need to understand why. We need to know what the purpose is of all of this, and I know Tom Campbell is the man to ask. So come on over, members, and the rest of you guys, we will see you next week.